Now, in its 25th year, its silver anniversary, the Philippine Mathematical Olympiad is going back on site in various test centers across the country after 2 years of online competitions. After its trial run in 1984, it was officially launched in 1986 and has been held annually since 2007. The country's contestants to the International Mathematical Olympiad are chosen from the top students who compete in the Philippine Mathematical Olympiad. The PMO is a project of the Mathematical Society of the Philippines and the Department of Science and Technology Science Education Institute, with official airline partner Cebu Pacific, and major sponsor Foundation for Upgrading the Standard of Education Incorporated. Hello everybody, welcome back to the Philippine Mathematical Olympiad video series. For today we're going to talk about some questions from the PMO aligning with the topic of stars and bars. So some textbooks, resources call this balls and urns technique, but for the sake of demonstration in this video, I'll refer to as stars and bars. Let's take a sample problem from the 21st PMO qualifying stage, so part 1, item 5. So this is the typical setup of stars and bars. So in this question, Juan has 4 distinct jars and a certain number of identical balls. The number of ways he can distribute the balls into the jars such that each jar has at least one ball is 56. How many balls does he have? Now, the typical setup of stars and bars is you have a distinct number of containers, so in this case jars. You're trying to distribute a certain number of identical balls. So you're distributing, okay, take note here, you have to be identical. So I'll show you now why. So identical balls into distinct jars. 4 balls for now. And then we want to split it into, let's say, 3 jars. One way of allocation is this. So the first jar has 1, the second jar has 2, the third jar has 1. And the jars will have to be distinct. So this will be the first one, the second one, the third one. So we could differentiate which is which. And the balls should be identical because, well, if I had the labels in the balls as well, then it's going to be a different case. For example, if I switch the third and the fourth ball over here. So that's a typical setup of stars and bars. Now, before we move on to solving this question, I'll show the general equation type or some of the possible translations in questions that involves the stars and bars technique. So these type of question gives us stars and bars vibes. So if you see an equation of variables, in this case, for example, a1, a2, a3, a1 plus a2 plus a3 equals 5, and we have a1, a2, a3 to be non-negative. So non-negative are just whole numbers. Non-negative, so positive plus the 0, so it's the 0, 1, and so on. And then we have positive integers, so 1, and so on. So there are ways to deal with separate cases, but just remember for now that whenever you have some number of variables, it doesn't have to be 3 variables for the sake of demonstration. I'm just using 3 variables, but if you see a certain number of variables adding to a certain integer, and the variables must be of integers, then it gives stars and bars vibes. So it's more likely than not, you're going to use stars and bars. So possible questions may include, how many ways are there to distribute 5 cookies to 3 friends? So that's 1. 5 cookies. Now the cookies are identical, so you can't really differentiate the cookies. It doesn't really matter if you give cookie 1 or cookie 2 to the first person and so on. And then the 3 friends, well, they should be distinct because you could differentiate the friends. So that's the same, that's kind of from the previous part, distinct jars and identical balls. Here we have identical cookies and distinct people, okay? So we could kind of have 5 cookies and then distribute to 3 friends. Maybe this would belong to the first one, this would belong to the second one, this will belong to the first one, the third one, like this. Next, how many 3-digit numbers have digits that add up to 5? Now this is not really an obvious stars and bars scenario, but we could, there's a lot of numbers, 122, 104, and so on. But to write this in terms of the stars and bars, let's just say we have the a sub 1 to be the first digit, a sub 2 to be the second digit, a sub 3 to be the third digit. And essentially we just have to find all the possible combinations, all the possible ordered triples, a1, a2, a3. So for example, 104 is going to work, 122. Well, in this case, it's non-negative and positive integers combined. So for example, A1, it must be a positive integer, so because it's the first number, but A2 and A3, we don't have much restrictions. It's just a digit from 0 to 9. Whereas in the previous question, well, we don't really have any restrictions, so although in this specific example, I made sure each friend has 1 cookie, but if it's not guaranteed that each friend would get a cookie, then it's possible to have like a distribution that's like 4, 0, and then 1. So that will be like the distribution. And that's going to be very crucial in answering some of these questions, because the stars and bars combinatorics formula, it specifies that we must have non-negative integer solutions. So let's just talk about the statement real quick. So the number of non-negative integer solutions, again, non-negative integer meaning whole numbers, so 0, 1, 2, and so on. And generally, if we have, in this case, n jars, so the jars must be distinct, so A1, A2, A3 are the number of, let's just say balls that you want to distribute into those n jars. And then adding them up gives us k. So this is like distributing k things into n places, n distinct jars, for example. And we have this formula, n plus k minus 1, choose n minus 1. It's a combination formula. Now, well, this is a very, it might be a technical statement, so you could kind of take a look at this alternative definition. We say that there are n plus k minus 1, choose n minus 1, ways to distribute k objects to n people. So that's going to answer the question a while ago, 5 cookies to 3 friends, and so on. And here we have this note, so no guarantee that everyone gets at least 1 object. So it's possible for us to have, let's just say in the previous example, 0 cookies to be distributed to a friend. Now, let's try to make sense of this formula, because there's actually a very nice way for us to visualize this. So in the stars and bars formula, I'll just use the 5 cookies to 3 friends scenario to illustrate. So 5 cookies to 3 friends. Let's just say each friend will get this many cookies, so I'll kind of allocate some space for them. And well, these 5 cookies, instead of trying to put stars into like the spaces over here, so instead of trying to put them one by one, the stars and bars formula, the reason why it's called the stars and bars formula is for us to be able to use bars, actually. And I'll write 2 additional stars here for now. But why 2 additional stars? That's going to be 1 less than 3, so 2, which is 1 less than 3. The reason being is I want to be able to use these 7 stars, so 7 resulting stars, and I'll make them all of the same color for now. So 7 stars, and I want to choose 2 of them to be bars. Now why 2 is because, for example, if I select this star and this star to be my bars, so I'll replace them with bars like this, then automatically we have split into 3 regions. This will belong to the first friend, this will belong to the second friend, this will belong to the third friend. So from 7 stars, so 5 plus 3 minus 1, 3 minus 1 because I need 2 bars, so 5 plus 2. So we have 7 objects in total. 2 of them must be our separations, our separators, the bars, so that the 5 objects will be distributed to 3 distinct, in this case, people. Okay? But obviously I could done the selection a bit differently. I could have selected this and that instead. So leading to the allocation 1 for the first, 0 for the second, and 4 for the third. 4 for the third person over here. Okay? Now, it's hard to count them one by one, but luckily we could just use the very simple concept. Well, we have 7 stars in total, and I want 2 of them to be bars, so we just use 7 choose 2. And in fact, if you actually substitute 5 cookies and 3 friends, so I'm distributing k objects. So here k would be 5, and the 3 here would be the n. So substituting into the formula, it's going to be 3 plus 5 minus 1. Choose 3 minus 1. And you see it's going to be exactly the same as 7 choose 2 based from our logic here. So you could try to experiment with other numbers, and the logic would be essentially the same. So that's how we, make sense of the stars and bars formula. So lahat ng formula may may dahilan yan, may mga proof at derivation yan. Okay? So let's go to a sample problem 1, which we just did. 5 cookies. So parang ito yung mga k objects. Tapos ito yung n. So just make sure na lang. So it's going to be 3. So n plus k minus 1. Choose n minus 1. So 7 choose 2. And that's going to give us 7 times 6 divided by 2 times 1. So that's going to give us 21. Okay. Now, for sample problem 2, yung sa 3-digit numbers kanina, medyo may iba kasi hindi lahat ng digits ay pwede maging 0. Especially yung unang digit, the first digit cannot be 0. Kasi sa stars and bars formula, sinabi na note, parang walang guarantee na merong isa sa lahat ng tao. For example, in the cookies a while ago. So we have to do something different here because yung A1 may restriction, kailangan ng isa. For A2, A3, walang tayong problema. So what we have to do here is, well, we start with 5 things and then we need 2 separators, tama? So we put 2 additional stars. And we have to make sure na sa pagpili natin, right? So let's just say we choose these 2. We have to make sure na yung unang digit, so your hundredths digit, may corresponding na isang, so at least 1 na star. So in this case, this would correspond to the 3-digit number na 113, 113. So kailangan lang natin i-make sure na may 1 tayo dito. So how do we do that? Now, siguro maraming paraan. Well, some of you might say that, oh, but edi wag natin piliin ito para meron tayong at least isa na nasa isang star na nasa left side. Ay tama naman. So we could actually do something like make sure na yung stars na nandito lang ang mapipili for bars. And that's actually going to be correct. So 6 stars na lang ang mapipili natin, and whatever pair you choose in these 6, it's going to correspond to a valid 3-digit number because may naiwan isang star dito. Okay? So here, we could do the stars and bars technique. So 6 choose 2 na lang ito, and that's going to be 15. Okay? So 15 3-digit numbers that have digits that add up to 5. Now, alternatively, I'll introduce something, no? It's called the saving process. I like to call it the saving process. Now, you're gonna save a certain number of stars for yung mga variables natin na medyo may kailangan. Here, it's the a sub 1. We need at least 1. So, we literally separate 1. So, we save 1 for now. And then, we proceed to do stars and bars with the remaining 6. Now, you might be asking, well, what if napili ko ang una? Like, it's going to correspond to 0, 1, 3. Eh, hindi siya valid number. But because you did the saving aspect, automatically you're going to add 1 to here. So, 0, 1, 3 would be corresponding to 1, 1, 3 din pala. And even if hindi ang pagpili mo ng bars, it's, let's just say, hindi mo napili ang una, that's okay. Let's just say, itong dalawang napili mo. So, mula sa 202, well, you still have to put this back ang pagka-save because para ma-satisfy ang digit sum na 5. Okay? So, this saving aspect is very important. So, you're going to see in some of the questions that we have to do. Okay? So, this is a very standard technique in stars and bars combinatorics. So, from sample problems 1 and 2, those are the basic stuff. Now, let's go answer a question from the 21st PMO. So, now that we know na, okay, ang concept pala is just distributing objects into jars. So, in this case, balls into jars. The only difference is that certain number of identical balls, we don't know. Let's just say it's n. But we do know the number of distinct jars. So, meron tayong 4 na jars. So, technically speaking, we know that this would correspond to the equation A1, A2, A3. Sorry, A1 plus A2 plus A3 plus A4 is equal to n. And all I have to do is just find the number of ways to distribute. The other thing is we have this restriction. Well, if the previous question, A1 lang yung kailangan ng na maging greater or equal to 1 because first digit siya ng 3-digit number. Here, all of them has to be greater than or equal to 1. So, well, kung ganun, then we try to look at this. So, let's just say we have n balls. We have to distribute into 4 jars. Note that we have to save in total 4 balls naman. Okay? Now, I don't know what n is for now, but I'll just say that using ... muna. And so this is n balls. So let's just say we have n balls over here. And we know that we have to save 4. So let me just save these 4. And then the remaining balls, so my n minus 4, we do normal stars and bars dito. Wala tayong restriction here. Okay? So we distribute the n minus 4 balls into the 4 jars, and then we put the saved balls back into the jars. So very similar to what we did a while ago. Okay? So we distribute n minus 4 balls into 4 jars. We could just use the formula. So going back to the formula, medyo weird kasi n yung ginamit ko rito, but should be fine. So ito yung para magiging k natin in the formula. Ito yung para magiging n. So n plus k minus 1. It's just going to be that. And then n minus 1 would just be 3. So it's going to be n minus 1 choose 3 kamo. Okay? And this will be the number of ways to distribute. Yan na yun. Okay? And going back, it's given here that the answer here is 56. So this should give us 56. So we could just kind of trial and error na lang, 9, 8, 7, 6. And, you can try one by one. If we try n equals 9, what's 8 choose 3? 8 choose 3 is 8 times 7 times 6 divided by 3 times 2 times 1. Ito na pala yun. So there we go. N will have to be equal to 9. Now, that's how we get the answer here. But just to kind of make sense of what I just said about the saving, now that we know that n is 9, we could try to be a bit more realistic in the examples. So we have 9 balls, and we need 3 separations to be able to distribute into 4 distinct jars. So I'll add 3 more. Okay, again, the color doesn't really matter, so I'll just add 3 more. And we know from these resulting, so 9 plus 3 na to, so 12. From these 12, we have to save muna because we have to make sure that each location or each jar would have at least 1. So let me put this here. And then we allocate, or we choose a separation. So we choose 3 from here to separate into 4. Let's just say we choose these 3. Again, we're going through all the possibilities, but just for demonstration, just to show you here. Now this would correspond to the answer now, okay? 1 in the first one, 0 sa second, 2, and then 2. Obviously, that's not 9 balls, but because we did save these 4 balls, so we're going to add 1 to everything. So it's going to correspond to 2 sa una, 1 sa pangalawa, 3 sa pangatlo, at pang-apat. So that's going to be the allocation. And this is a valid allocation kasi if ever na may mga 0 here, in this case my 0 here, it's going to get added 1 naman. So at least 1 ball will be in the jars. Okay, so there we go. And a very similar problem has appeared in the 22nd PMO qualifying stage, part 1, item 10. So suppose that n identical promo coupons are to be distributed to a group of people with no assurance that everyone will get a coupon. So in contrast to the previous question, dito naman, no assurance na lahat ay meron. So we don't have to do the saving. No problem. Now, medyo iba lang yung tanong na there are 165 more ways to distribute these to 4 people than there are ways to distribute these to 3 people. So we have to take into consideration 2 scenarios, no? So 4 people, pati 3 people. So again, note that we do not need to save coupons, and we just have to take a look at these 2. So distributing n coupons to 4 people, well, since no restrictions, diretsong pasok na agad sa formula ng stars and bars. Again, it's a bit confusing kung bakit n yung ginamit here, but going back to the formula kamo, this will be your n. So you're arranging k objects into n jars, for example. So ito para magiging k. It's a bit weird because we have to follow the formula, but anyways, so n plus k minus 1, choose n minus 1. So n plus 3, choose 3. So that's number of ways to distribute n coupons to 4 people. And then in the second one, distributing n coupons to 3 people. Again, this would serve as your k, this would serve as your n in the stars and bars formula. So n plus k minus 1, choose n minus 1. This would be n plus 2, choose 2. Now, going back to the question, there are 165 more ways to distribute these to 4 people. So just combine these 2 kamo. So n plus 3, choose 3, minus n plus 2, choose 2, it's gonna give you ano pala? It's gonna give you 165. And buti here we have choices, no? So we can just kind of substitute them in. Although kapag wala, then we will probably have to expand this. But since meron, we could just kind of substitute it in. The choices are 12, 11, 10, 9. Let me just start with let me just start with the smallest one, 9. Kapag 9, it's gonna be 12 choose 3 minus 11 choose 2. Okay, now 12 choose 3 is 12 times 11 times 10 divided by 3 times 2 times 1. Then 11 choose 2 is 11 times 10 divided by 2 times 1. Now the first one, yung 3 and 2 cancels with the 12 nicely. So 2 na lang yan. So ito 220. So una, 2 times 11 times 10. Then minus, these two cancel out. And 220 minus, oh okay, ito na pala yun. So that actually gives us 165. So again, if we don't have the choices, we would have to kind of expand this to solve. But luckily we are given the choices, kaya diretsong substitute na lang. From the 21st PMO question and the 22nd PMO qualifying stage questions, those are medyo direct applications down stars and bars. Now here for the final question that we're going to talk about, let's talk about the 21st PMO area stage question. So ito wala tayong choices to try. First thing to notice is hindi obvious ang application ng stars and bars here. Kasi hindi siya distributing stuff into jars or distributing cookies to friends kind of vibes. So sige, basahin muna natin. In how many ways can the letters of the word combinatorics be arranged so that the letters COACTORS, so co-actors, appear in that order in the arrangement, although there may be letters in between. Now, technically speaking, etong although there may be letters in between is actually a good indication na merong allocation na mangyayari. Because we just have to distribute M, B, I, and I, so limang letters, into some of the spaces in between the letters. We have a total of 9 spaces for us to put 5 letters. So the first part, kamo, is just finding the allocation. Okay, so let's just say we're gonna put M here, B here, I, N, and then I dito. Okay, now, so this is gonna correspond to the string of letters siguro. M, C, O, B, A, I, C, T, N, O, R, I, S. So coming, reading from left to right, kamo. But take note that we could permute the letters from left to right, and it's gonna form a different thing. Okay, so for each of the kind of distributions, so distributing 1 here, 0 here, 1 here, 1 here, 0 here. So this allocation, and then we have to take into consideration the permutations of the letters as well. Pero we could try to, write down our thoughts muna. So first, we decide the allocation of the letters in the boxes. And then what we do is arrange the letters placed in the boxes, kamo. Okay? So going back, well, since we're deciding on the allocation, we can now think about, okay, essentially I'm distributing 5 objects, in this case letters, 5 letters into 9 spaces. So 9 spaces yung nasa ito mga squares natin, no? Ito mga boxes. So 5 objects into 9 jars kind of vibes. It's going to be, so N ating ay magiging 9, and then yung K ay magiging 5, going back to the stars and bars formula. So there's going to be 9 plus 5 minus 1. Choose 9 minus 1. And it's going to give you 13 choose 8 ways for you to distribute, decide on the allocation of the letters in the boxes, kamo. Okay, now we could solve for this. 13 times 12 times 11 times 10 times 9. 5, 4, 3, 2, 1. The 5 and the 2 cancel very nice with the 10. 4 and 3 cancel with the 12. Onting effort na lang here. 13 times 11 times 9. That's going to give you 1287. Okay, now arrange the letters placed in the boxes. Now, because as you can see, well, we have to take into consideration the permutations of the M, B, I, and I as well. So we have to permute M, B, I, and I. So this is a very simple permutation question na lang. So 5 factorial. So 5 objects, pero naulit ang I. So account for the 2 I's by the 2 factorial there. So may 60 tayong extra here. So, well, that's essentially it, right? So 1287 is how we allocate the letters first, and then we permute the letters. So our final answer should be the product of the two. So we do the allocation first, and then we multiply this by 60 to get the total number of ways of doing both. So that's going to correspond to total number of the permutations of the letters of the word combinatorics natin. Okay? 77220, 77,220. Not an obvious application of the stars and bars combinatorics, but with the correct kind of reasoning, with the correct motivation, it's not going to be a that difficult of a question. I hope you guys learned something new from the video, and if you get stuck, feel free to go back, because it is very difficult to understand some of the more difficult concept of stars and bars, particularly the saving, and then probably this item from the area stage. Okay, but that's all for now. I'll see you in the future PMO videos. Bye bye.